Hello, everyone. We have Michael Meeks with us, and he'll be sharing his thoughts on working with ancient code bases like LibreOffice. Over to Michael.
Hey, thank you. Hopefully I'm turned on. Hello. I don't know how this thing works, so I just fiddle with this after fiddling with the screen for a while. Do you want to? Yeah, if you've helped, I would like the lapel mic if I can have it. Cool. So let me do the slide. Ooh. And you can't make these things up, can you? Password required. I think this is VLC behind the scenes doing something awesome. Yeah. Okay, perfect. This is what I'm going to talk about, so I won't tell you what that says. I'll just do it. So, restructuring a giant code base. So we have a unique and exciting problem in LibreOffice, which is we have a 30-year-old code base, and it's gigantic. It's 8 million lines, or, well, depending how you count them. I mean, it's quite big. And the great thing is that it's got the strata of lots of different problems inside it. Oh, hello. Oh, this is now intimate. Oh, very intimate. Thank you. Yes, I'll put that in here. That's great. And there's lots of different things going on in there. So LibreOffice, you may not know, grew out of the object-oriented mania of 30 years ago. People discovered object orientation, and they were overwhelmed with their ingenuity and cleverness. And they were convinced that this was going to solve all programming problems. It was the silver bullet. And so Marco Burriers created an object-oriented graphical toolkit as a young teen in his parents' garage. So you need your parents to have a garage. They're increasingly less popular these days, but it's a vital part of innovation. That and the water cooler. So buy one on Amazon. Anyway, so he created an object-oriented toolkit, and it was reasonably successful. He grew a company, but communicating with the customers was a problem. Like, they didn't grasp how silver bullet-y object-oriented toolkits were. And so they created some demo applications to show off the raw power of the approach. And the customers were much more interested in the demo applications than the toolkit, as I understand it. And so, unfortunately, many of the original design decisions were laid down on the basis that this was a throwaway application that I'm just going to write for, So whereas if you go and listen to the Microsoft Distinguished Engineer and he talks about the brilliant people that wrote Microsoft Office and says, the piece table design is still what we're using today 30 years later, it's absolutely brilliant. To some degree we're cursing the bad design decisions and getting rid of them. So there's a lot of restructuring that's been needed, quite a lot of it going on. So when you try and restructure a big code base, the first real choice you need is, so what language should we use, and particularly pertinent today. And then, what platform should we target? And the quote at the bottom is Larry Ellison, who's, if you haven't heard his "What the hell is cloud computing" rant, you really should. It's extremely instructional and very funny and probably obsolete. But anyway, so my tip one, I have relatively few patronizing tips. But there is actually, I think, still no silver bullet. So if you meet a silver bullet salesperson, you might want to see, try filing the thing a bit and seeing if it's silver all the way down, for a start. Here are some silver bullets I've seen. Object-oriented programming, of course, a seminal, moment. Java lets you develop 10 times faster. Garbage collection is absolutely amazing, and it's going to solve all known life cycle problems. C#, interestingly, also helps you develop 10 times faster. So I don't know if it's that 10 times faster than Java. Maybe it's only twice as fast. But there's some good things there. The syntactic sugar of C# is infecting other people. They start to think that programming shouldn't be a long and laborious process where you type unnecessarily large statements and you feel good because you can parse them mentally. Maybe we could have simple stuff that we can understand. Vala, of course, is, as everyone knows, a modern language with, yes, all the features you'd expect. A wonderful preprocessor-based, well, I don't know. I can't take the mickey out of Vala. But what I would say is that there were people, back in the day, I worked on GNOME, and I used Evolution. I was part of the team, privileged to be part of the team for a while. And Vala was created, and a whole load of people arrived and decided they were going to rewrite Evolution in Vala. The only difference being the language. Still GNOME, still GTK, still whatever. But what we need to do is rewrite the work of a team of 50 people for years in this new language. So I don't know, it didn't work as far as I'm aware. There's probably some software still there, but anyway, it goes on and on, this kind of craziness. And as such, I think probably my personal favorite is another great Larry Ellison quote, which is, quickly build their version of a spreadsheet word processing app using JavaFX. So according to the register anyway. Now Larry made a fatal mistake, or someone in Java made a big mistake here, which was to use a name that can actually be Googled, and you can actually see the trend on. Now most people, when they create a new language, I mean apart from Haskell of course, you use a name that you can hide very easily. Ruby, like Rust. Go being a particularly awesome example of this thing. I mean, the Go trend is just completely flat over all time. Z-Squat is just the terrible name. Like, don't use this name. And the reason is that, I've seen the Gartner hype cycle. Who's seen the Gartner hype cycle? I mean, it's been fed to me my whole life, and I've never believed it, right? I thought these guys are complete idiots. They're management consultants trying to sell something to me. Like, why would I buy that? Anyway, Google trend for JavaFX, and you see, there's this peak of whatever, maybe there's two peaks, marketing really getting their act together. And this is the recommendation to use JavaFX, just before the trough of total gloom and the utter, the suffering of this, and then the, oh dear, how did we end up with this technology? What are we going to do about it? How can we possibly make it actually work? And so on, But it's nice to see that there is actually some slight factual basis behind some of the things that we're told. A quote I particularly like is, and you can watch the talk, this is from Iger Zike, who's a distinguished engineer at Microsoft. And I'm no language bigot. I mean, choose whatever you like, but just don't switch it every few weeks. 30 years of C to C++ to, actually a language that can be innovated. And, since I wrestle with a giant and awful code base, increasingly good code base, I'd like to try and persuade you that actually existing languages are things that can be evolved and improved. Yes, it's really painful. Yes, you have to go to standards bodies. But actually writing entirely new languages is quite painful. Although there's lots of talks at conferences about them. So yes, I think these are the typical risks that happen. So I'm not a language bigot, choose what you like, but it's the other particularly sad thing as you come to refactor your code is that it's a huge driver of duplication, language choice. I see perfectly well-meaning people who I love dearly who think that it's important to rewrite something totally in this new thing. And I've seen this again and again with Java, with C#, with... I won't go any further. But anyway, and if you look at web technologies, there are a whole plethora of duplicate web technologies that to me appear indistinguishable. And the only real difference between them is that one is in PHP, one is in Ruby, one is in, whatever I don't know. There's a great stable of these, right? And you think, guys, why can't we? Anyway, this is because I'm ignorant. The problem is, of course, that LibreOffice over a long time has adopted a number of these and cargo-culted languages. I think one of my favorites is the JavaScript scripting framework written in Java called Rhino that we have, which, as you know, the Java is 10 times more productive than anything else. So it's very easy to write a JavaScript interpreter in it, and then it sits around in the code. We're slowly trying to write out Java, and not because we dislike Java, it's a perfectly good language, but you can't guarantee that it's actually everywhere, which is the slight irony of the write once, run everywhere message, that actually it's write once, and then try and install this thing of a certain version on all your Windows hardware forever. So there's some good work actually funded by TDF and our donors to get rid of HSQLDB, which is the last sort of blocking thing for that. So some language choices you need to make. And there's some API choices you need to make too. So we're particularly blessed in LibreOffice by being a cross-platform app that runs on any platform you might like to think about, including, I was thrilled to see Haiku the other day. So the BIOS clone. Luckily, I know nothing about that, but these are some of the major APIs here. So the Windows rendering APIs that we actually use to actually render LibreOffice on nearly 200 million machines is actually the GDI API, which came out with Windows 1, and it was initially a 16-bit API, and it seems to have made the transition to 32-bit and now 64-bit quite cleanly, which is slightly baffling, isn't it? It has features like not having any alpha transparency unless you have separate alpha buffers that have been tacked on later into the API and this sort of thing. We also use Direct Write from 2007, which finally provided you a way to actually choose which font, which glyphs you're actually getting. Because GDI does like a font config, font substitution underneath you in a completely unpredictable way. You have no idea what happens. And there's loads of code if you look in your Chromium browser, they try and work out what it is by rendering to a meta file and then parsing manually the meta file to try and work out which font was used to which glyph there's some exciting stuff there. So direct write finally does it sort of right, but doesn't work very well still in lots of places, 10 years on from its creation. So one of the things I like to point out is that, as you restructure, it's easy to choose the latest, greatest API, but will it really be there tomorrow? It's very difficult to know, isn't it? Of course, in the same time, the Linux world has managed to go through quite a number of toolkits, several of which we support concurrently. So people also like to tell me off for wrapping stuff, like why do you wrap platform APIs? Why would anyone do that dumb thing? We have a perfectly good API. Like, why do you put this wrapper around it? That must be evil. I hope it becomes relatively obvious why. Not only the cross-platform aspect, but also the fact that it keeps changing. So I think we're getting to Qt5 from 2012. I think there's still some work going on to make that work. Is that right, Torsten? Somewhere? Actually, yeah. So anyway, the platform churns far faster than you can update a multi-million line application to use it, which is slightly distressing, despite all of the work that goes in to actually improve the stuff. And then, of course, there's the whole form factor thing. What should you be targeting? There's a constant evolution of trendy platforms. The audio assistant one is particularly fun. We're looking forward to seeing that. And then, of course, the hardware people are busily at work trying to overcome, the fundamental problems of physics and scaling things by making processors much wider and frustratingly insecure. By improving their IPC, obviously, speculatively. We also have a wonderful thing in recent times, which actually gives us hard numbers, crash reporting statistics. Marcus has produced and produces lovely data. So of the 2 million plus crashes that we analyzed, we're getting more threads. Like, it's real. We need to actually do something about threading. Although the gradient is not very quick. This is a year of data. But you can see that the one CPU people, who are presumably, I don't know where you find a one-core CPU. But anyway, there are people that manage to do it at the 3% level. And this is probably not Raspberry Pis either, because Linux distributions compile this stuff out. This is mostly Windows users. But yes, anyway, there's lots of threads coming along, and the cool kids who have the 80-core machines are growing, this is clearly the future coming here. Sadly, there's cores, not threads. It's quite possible that threads are the double that in many cases. So let's talk about threading. So one of the things we need to do then is to try and use all this hardware that's on the die but not actually being used. So we've done a whole load of work there to try and do this, and we do this in a way that is extremely compartmentalized. So it's nice. So there's two approaches we have to threading. One is a very generic UNO-based approach with a COM-like scripting framework called UNO. And in theory, it's highly thread-safe and stuff. But the reality is that extremely granular APIs that are useful for scripting, understandable by individuals, not like teams of people, turn out to be really, really bad for performance and really hard to implement, just because threading is really, really hard. And you really want to message pass if you can, but your API doesn't look nice if you message pass. So, so we have UNO, and so that kind of threading is there, but it was still sort of 1 plus epsilon threads. That was Tarasclex, nice thing from Mozilla. We just, we do a lot of threading, we do a lot of locking, but we don't get any parallelism. So, all of the downsides and none of the upsides. So actually it turns out to be much more effective to find one piece of code that's at least reasonably, like you could scoop it out of the patient, like and put some threading around it. So for example, image scaling for various reasons. We still do CPU image scaling for high fidelity something or others on lots of places. And it's a beautiful parallelism piece. It's completely safe, and you can convince yourself after reading it for some hours that it's probably going to be safe. And you would think that's funny, like the XML parsing thing that I'll show you in a minute. We also read very carefully, thought was safe, and shipped for years, and then of course, you find the threading bug in it, which is slightly worrying. The rendering rasterizers, Armin's done a fantastic job of turning all of this clever primitive decomposition, CPU, software rendering stuff into something that parallelizes as well. So if you have a 3D something intersected with something else in the draw application, it works quickly. Complicated charts, I guess, probably benefit from that too. The calc core, I'll talk about in a minute, but again, desperately trying to find something that is a piece you can chop out and wave your hands and persuade yourself is safe in the middle of that. XML parsing I particularly like because people are interested in XML parsing, particularly that it's extremely slow. How can it possibly be that slow? And I think you have to go back and blame the authors of the spec, really, I don't know. Like Jason has a lot to say for it. But either way, people come up to me and say, I have this brilliant new idea for parsing XML. It's going to be so fast. We're going to memory map the file. We're going to use pointers to something or other. We're going to copy it into buffers, and we're going to do very little work. That's really interesting. That'll be a lot quicker. So the problem that I have is that I have a constant time XML parser. It parses any size XML file in a constant time. And can you beat that? It's kind of a nasty trick, really. But you saw the CPU, the graph, right? There are all these threads sitting around there not doing anything, right? So, I just cheat. I just shove one of these in at the bottom. And so, effectively, we have a SAX API. The SAX API is incredibly inefficient. It's really not designed well. The worst thing you can do for a CPU iCache and Dcache and whatever is to do a very little bits of work that then create lots of other work that then comes back and does another little bit of the same sort of work. And so there's an unzipping bit, there's a parsing bit, there's a tokenizing bit, there's all these things. And then it disappears off into la la land, into the calc core filter, and it comes back again, and it's a disaster. Anyway, see, it turns out that even if you don't have two threads, doing a whole load of parsing, storing the results, and then emitting all the events that you got from it is actually good news. Anyway, so this is nice. So we get, the fixed cost then is only really true if your consumption is slower than your parsing. Obviously, you have to balance these things. But actually, we try and move some degree of work between these two threads dynamically, depending on who's more and less busy, which is quite fun. So, yeah, that's good. So there's some setup time as you parse your first swing buffer full of events, which is the kind of constant. What else? So we've been trying to thread calc, as I mentioned, and there's some heroes, Tor Lilquist and Dennis Francis, have been doing some work for me on this, and they, so we have this thing called SC Interpreter that calculates every single cell in your spreadsheet. Every formula is a stack-based reverse Polish. It's great. And so we're trying to cut this thing out. It seems like it might be something reasonably separable. And then you discover that actually the token array, which describes the formula, is being mutated as you iterate over it. Like the iteration index in the ancient code is stored as a member variable of the token array. So, two threads. Yeah, not very nice. And of course, macros have access via this Uno API to the whole model. They can delete the formula that you're editing while you're doing it. That's great. And then, of course, some of these formulae actually mutate the dependency structures, which are document-based. And if you parallelize this, you again have major fun. And then there's a whole load of other stuff that's mutated in the document, and then caches that are built. But after a while, hopefully, you can chop enough muck out of this that you can shrink the domain enough that you can, again, persuade yourself that this might actually be safe to do. We put a whole load of asserts in there. So we in my old age of having been a type safety bigot, I'm turning into a thread safety runtime checking Python loose type person. Luckily, we have some very large data sets, so actually loading and calculating some of these documents gives some nice assertion failures. We're still working on rooting out here. But yeah, so it's some quite fun, and it actually gives you some reasonable good results too. If you want a nice 16-core machine, let me advertise AMD, who produce some very nice ones, and at a reasonable cost too. Look at that. And they funded a chunk of this work. This is my lame Linux laptop, and the Windows one just happens to be a much faster machine, as you see. So that's why it's only taking half the time. Yeah, so what can I say? It gets quicker, but not 16 times quicker. Particularly the hyper-threading is not nearly as good as you might hope for, well, particularly obviously heavy floating point loads. Yeah, so what I'd really like to see is some language support. So what I need is some innovative people who love thread safety and love improving languages to go and persuade the C++ Standards Committee that having some kind of really restricted subset that does a lot more checking would be good. The C++ Standards Committee are still trying to study the problem of having built-in primitives like threads and mutexes and things like that. But hopefully we can get them past this and into the fertile ground of language innovation and include all this good stuff into, I don't know. If you're crazy, come and see me later. I can sell you some swampland as well. Good. So there's a whole lot more to do there. And of course, at the same time, we're trying to clean the code up so people can get into it. So one of the great things here is the German comment translation. These are the people who actually finally got the curve down. You see this, I'm very proud of this bit here, you know. There are lots of people that start projects, but this looked really like an exponential decay to me, and I was getting pretty frustrated by here. And I said, look, and bang, you know, these people turned up. Brilliant, Jens Karl, you know, Johnny M. They said, right, we're going to finally fix this. Of course, there is a single German comment left. Well, actually, there are probably some we can't detect easily, you know, just for old time's sake, you know, so you can see some particularly fruity examples of how not to do it. Yes, less eye strain horror. So, of course, the code base is very old, and yeah, I don't know, this is how we used to create strings with this RTL OU string, RTL const ASCII U string param string. Yes. Anyway, in the modern world of magic templates, you know, you can not only compile very, very slowly, but you can make the code look nice. And actually, you know, human time is much more valuable than compile time, perhaps. We also have pretty iterators in this world. You know, it turns out that, you know, virtuous as you feel, having typed this great long beast, managed to get it compile and understood the error message when it doesn't compile, it's a heck of a lot simpler to do just that. And so there's a large-scale code cleanup thing here, shrinking lines and, you know, making everything good. And a huge tool there, and I say this with some degree of sadness because I'm an FSF lover and Richard Stallman, I have a soft spot for the man, you know. But GCC is well on the way out, and Clang is just doing awesome stuff. So we have a whole load of Clang plugins doing automatic rewriting, effectively expanding C++ for our use case in some cases, but also generically with some really, really nice tools. You know, I mean, the unused field checker is something that everyone should use, right? It looks at your giant corpus of code and goes, you realize you got this field, that field, this thing, and no one's actually using them. You might want to consider, you know, actually removing them. Default parameters, you know, unnecessarily devirtualization and so on. So just trying to clean stuff up. And these are only the ones that have sort of been most used in the last few weeks. There's whole loads of changes going in there. And also some sort of aesthetic ones too, you know, making this function look less ugly by deconfusing its logic in various ways, which is quite cool. So I'm a fan of that. And then cleaning up other stuff. So I mentioned our GDI. We also have Apple, you know, have a Cortex API for shaping stuff. Windows, we were using Uniscribe directly. All of these APIs, of course, are changing slowly. And we thought, wouldn't it be nice if we could use a single cross-platform free software thing that we can look in the box and it lays text out the same everywhere. It shapes it. So thankfully, due to our wonderful donors and the Document Foundation's funding, Khaled Hosni, who's a wonderful Egyptian chap, has basically moved us all to use half bars on every platform, which is brilliant. And we would love, I would love at least, to use free type everywhere as well to render pixels. Because then at least you're 100% sure the pixels are just identical everywhere. The slight problem with this is on Windows, in order to print, you need to use GDI. It may not be obvious to you, but a lot of applications are just drawing on a very big version of the screen. You know, it's all in pixels, what comes out of your PostScript printer inside Windows. And of course, if you want a native platform window, you know, print dialog, and you don't want to send lots of pixels to the printer, you're kind of doomed to use GDI, or GDI Plus, or Direct2D, or you could generate the PDF equivalent that Microsoft forked, which is called XPS. I think there's some kind of hook where you can shove that in and still use the native platform thing. So it's kind of a bit irritating when you're a WYSIWYG word processor and it's important to you that what comes out of the printer is actually what's on the screen. Now, I know we are a very small use case in actually carrying out paper still, and the web browsers don't have this problem. What comes out of the printer bears very little relation to what's shown on the screen. So, but we actually really care that those glyphs are really there, and that's a bit of a downer. And it would be great to come up with a solution that works in Windows. Drawing layer primitives, so increasingly just moving to new and cleaner rendering models that work really well. So again, Armin has done some great work there. Quailon has been doing another thing. So there's an eternal tension between having widgets that are native platform widgets and having code that's easy to port and works everywhere. And of course, we have both. So that's very important. And there's various ways of achieving both. We have our built-in UI toolkit that's now actually used again for Collabora Online or LibreOffice Online. And you can see the full glory of what widgets looked like in the 90s, with their hand-drawn bevels and that sort of thing. Yes, it's amazing. We're going almost back to that, the whole flat UI look. Actually, it's not too different. Anyway, so, but to make things look pretty and to make the black-on-black theme work that everyone wants, we sort of capture roaming widgets from different toolkits and we torture them into making, the pixels we want. And it's not very great. We miss a whole load of animations and other stuff. And so we've tried to tease pieces out of that. The native menu bars and files. I mean, file selector is just a must. Obviously, that's been there forever. Tooltips. So really, Quaylon is a hero here. Finished converting all of our dialogues to Glade XML. So we have actually a file format that's reasonably editable. We have an editor for that now, which is useful. Previously, it was all done in TWIPs, and the TWIPs were scaled. So we knew that German is a longer language, so you should increase your font size horizontally, like all of the positions of everything, by 50%, something like that. But if it's Chinese, we know it's a much shorter language, so we should shrink all the positions by, say, half, so that it looks nice. And it turns out that actually doing proper layout is better. And you laugh, but I talked to the VCL object-oriented class library people, and they said, yes, we made a deliberate decision not to do automatic layout, because a human being can always lay out the dialogue better. I'm not kidding. But whether he can lay it out in 156 languages, better is, It turns out he never has the time, so better to do a bad job. And so anyway, there's nearly 1,000 of these UI files. And another thing people say to me is, why don't you do a Firefox, like strip down to the bare essentials, or a Chrome, which is perhaps even more extreme, remove everything, right? And well, part of the reason is that we have nearly 1,000 dialogues in the product. And there are lots of complex features in each of those. There are many tabs, and just the surface that you need to actually control what your document is doing, how it lays out, is staggeringly vast. I tried to grasp how many UI files there were in the whole of GNOME, like all of these things on my disk from the rest of the desktop in total. And it gave me a suspiciously smaller number of this, of the order of about 200. But if you can repeat that on your laptop and tell me the answer later, I'd be pleased to know. It's hard to grasp the scale and bigness of what's there. And the good news is now, Quaylon's done some fantastic work making it actually load UI files. So if I can try and get my VLC to show you, I can show you a demo of his work here, really. So this is LibreOffice, if you haven't seen it. And this is a dialogue. And this dialogue is actually using GTK. So it's a GTK dialogue. And these widgets, you can see the surrounds there. You're going blue. You can see the fading out things here. You can see as you move, it's got some degree of beautiful transitions. This thing on the right here is actually a VCL rendered preview thing, because that's kind of hard to, you can't port that to GTK. It's just like tons of work. We have those, and there's lots of weird, I'll play it again because it's obviously too cool. I don't know if you're appreciating the goodness of the pixels in the background and the intrinsic value here, but it's nice to have that. And then of course the theming is really good. It should work beautifully and not like a squatting alien for those corners where, I mean, I'm not prejudiced against aliens, I would point out. I'm an alien lover. But yeah, here we go. So there you go. So some great work there from Quaylon. I'm really impressed. And of course that leaves us sort of in a WX widgets sort of situation where in some cases then we're using these native things. And you can see some things there where there's actually kind of bugs and the horrible theming stuff. The page breaks around, focus around is knackered. This thing is not working nicely and so on. So actual improvements as well. Other things we're doing to try and clean up are things like the security work that's going on. So OSS Fuzz is rocking my world and my mailbox as it spams me regularly, but many other people. And again, Quaylon here is just a hero for fixing endless things. So there's a 1,000-core cluster, perhaps more, there that Google are providing to run AFL under ASAN. And, well, I don't know, if you have a large C, C++, anything that compiles to binaries, that can be executed by AFL, you really need to be plugged into this guy. It's just unbelievably good. And people come to me and talk about manual auditing still. Generous, lovely, wonderful people. And I try and persuade them that actually, in fact, manual auditing is dead. We all know that robots are going to drive our cars. It's inevitable. probably into walls initially. But in the end, it'll all be good, and walls will get softer, and it'll all be fine. But one of the easiest tasks, is some of the stuff we're seeing, like the Clang plugins that are starting to do a whole lot of code cleanup tasks that engineers can do automatically. That's only going to grow. But one of the perhaps most tedious tasks in the world is auditing. Following the consequences of this integer being slightly too large through the code and the exact side effects of that, or following the life cycle of this or this index into some other thing or where it's dereferenced, and following all of those back through the code, back to the file or untrusted data. There are people that still do this, and they drink coffee, I hope, lots of it, and they prop their eyelids open with matches, and they do find things. However, the problem is that when they've gone away and heavily audited the random number generation scheme in SSH and Debian, the problem is that next week someone comes in and, so there is still a role for manual auditing, as you can see, functionally. But they carefully audited this binary code checking thing, and the next week someone comes and commits a patch that looks perfectly innocuous, that breaks exactly this code path. And the great thing is that OSS Fuzz starts to show us these things within a few days. So simply because it's there, it's got this huge corpus, and it's updating very regularly and following master. And it's got genetic algorithms and AI and backpropagation. It's just an amazing thing. It sits there and it finds the problems before they can escape, which is just fantastic. So the benefit of hooking it up and consuming an entire North Pole's worth of electricity somewhere else is that you have security in the longer run, which is great. Of course, Kverity is a great static checking tool, and Kverity Scan we're very grateful to, and our score is still lower than that of the Linux kernel. Now, I'm not claiming that means that we're more secure than the Linux kernel, Samba, or I don't know, whatever else you happen to be running, but it's nice. You've got to tease these people, haven't you? So we do all this rampant and rabid refactoring or fixing and cleanups and all this sort of stuff that there's no commercial justification for, you might think. Except that if you don't do them, your code will become like a relic, and not a very holy one either. So one of the things we do to try and stop this becoming a real problem is unit testing. And you'll see that the graph almost looks like it's going upwards. Like 6.0, there's even more unit test asserts. I'm a lover of unit tests, and we need more and more of these, and this is why there's a great credit list. These guys did greater than 20 commits to unit tests in the last year. So they're my heroes. Look at that. Fix each bug just once. Don't continually fix it. There's plenty of jobs for life in LibreOffice without needing to refix the same bug. And then, of course, refactors, as we all know, just cause regressions and don't do any good for anyone. So how do the stats look? Well, we track our bugs very, very carefully, and the QA team is awesome. Raal is here. I think Cisco is here. Is Raal here? Yeah, waving over there. And so we tag regressions very nicely, and so we look at these. And so over the last year, we've had about 33,000 commits, and our open regression count has gone up by 142, which sounds bad. I'll talk about it in a minute. But that's one effectively lingering regression for 0.4% of commits. And I think this is a reasonable ratio. It's not for free. There's a lot of work going in there. There's something like 2,000 closed regressions in that time that we've created and killed. So many of those didn't escape. Thanks again to the QA team that tested before they hit the masses. Of course, there's always one or two embarrassments in the early series. But and how serious are they? Well, of course, we also try and triage the most irritating of these and make sure that they're addressed really quickly and they don't escape. I'd just like to persuade you that some bug fixes rob Peter to pay Paul. So one of our problems is that some of our bugs of the form, I click on the file and then I go and make a coffee, and when I come back it's opened. Now, there are increasingly few of these, and we're doing some great work, but often we have to do a trade-off between, well, let's make this case much quicker, but unfortunately this minority case will get slower. And this is a regression minefield, this minority case that you think has one extremely vocal user who files a regression saying everything got 100 times faster for 90% of people, but my 2% use case got half as quick. What are you doing? You idiot. And so you get these regression bugs, and of course you could revert the patch, but the problem is you shipped it now, so now you get 98% of the people going, what? It got 900 times slower. So what are you doing? So to some degree there's an eternal nature to regressions, and that's my excuse for it going up slightly. Anyway, I think there are other causes for that too, and we should probably fix more regressions. But at least in theory, it sounds plausible. What else? Okay, so online provides an entirely different platform. So the difference between having your software on client side, rendering to a single desktop, versus server side is quite noticeable in terms of how we structure our code and what we optimize for. And if you haven't seen it, LibreOffice Online, Collabora Online is just awesome. You should go and play with it and tell your friends. But the optimizations are completely different. So on the PC, we're trying to avoid loading stuff off the disk because disks used to spin and they were slow. And memory is precious, so why fill it full of stuff you don't need? So there's all of this componentization splitting into smaller pieces. But online, we hate that because, well, it'll become apparent. We actually DL open all of these things and we link them day one. So we're like, yeah, let's take a 150 megabyte, 200 megabyte hit, straight out. And multiple seconds. If it takes 10 seconds to start, no problem. Let's load all of the dictionaries and all of the hyphenation patterns as well as we start. Because having done this, we can then fork our children that have this wonderful copy on write thing. They don't need to load any dictionaries, any code. They don't need to do any linking. It's all just there. They just use it. So we deliberately go wasting memory in our pre-initialization left and right, and we waste CPU time, and we should really waste more CPU time and more memory. Though we have some good ideas of ways to make it bigger and so on. And if you use Java, EJBs or something like Java startup time seems to have heavily focused on the server side of this, which is perhaps why it's not succeeding on the desktop. So having done all of this wonderful copy on write sharing work, the problem is that then we fork, and our children, if we're not careful, go and then touch those pages, which is really bad because every touch you have to actually physically duplicate it. And depressingly, often having touched it, you then put it back to where it was. So I wrote a little tool. It could be really useful actually for things like KDE init, if it's still in use, web servers, that starts to look at your memory as compared to your parents' memory, and which pages the operating system is sharing, and which pages are actually different, which is actually a different set. So there's actually quite a number of pages that were once touched and are now the same. This is just a little example of its output. So this is a string that says mathml 2.0. I don't know why it says that. I don't really care. But you'll notice that there was a 3 at the beginning of it, and the parent had 1. So as we forked and did something, we incremented the reference count, and in doing so, we wasted a 4K page. Now, one 4K page I can cope with. But when there are lots of them, this is not good. So actually, creating the tool helps us save some significant chunks of memory. We staticize all these strings so the reference counts aren't mutated now. We have a different startup allocator that handles this, which is kind of nice. And so it can give you all these statistics saying, how many of these pages are dirtied. What I really like is to integrate it with Massif or something like that so that we can say, this non-string toxic bit of memory I can't understand that looks very repetitive and weird actually was allocated by this stuff, which would be kind of nice. Perhaps there is a tool for that already. Julian will tell me in a minute. The other thing about memory use is that you find some interesting things in the code. So we use Cairo to render fonts on the server, and these comments are particularly encouraging when you're trying to find why there's sort of 40 meg of stuff for a relatively simple document hanging around. Yeah, these numbers are arbitrary. We've never done any measurements. Well, we did some measurements, and it turns out that having, for example, a fixed number of glyphs that you cache independent of their size is not necessarily a good thing. So if you work on Cairo or Pixman, maybe you'll get some patches from us soon. But possibly we actually need to take advantage of this and pre-render a whole load of glyphs in common fonts, in common sizes, Arial 12 point or the equivalent, so that then we have all of these things ready. We don't actually need to allocate any memory. It's just a blitting experience. We've been tunneling dialogues, which is particularly encouraging. And I've said a lot of things that could be interpreted as LibreOffice has problems. But actually, there's some huge strengths. Doing this online stuff, Kendi and his team have been actually enabling this. Pranav Kant is the guy working on this at Collabora. We've been pushing these dialogues through to the client. So it's a bit like a VNC, but it's collaborative. And so you can then have the same similar selection of text. You can have multiple people popping up copies of this dialogue. And one can change the border, one can change the color, one can edit the size of the text, commit it, and it all works. And that's pretty nice. And actually, the work to make it all work, well, is ongoing and requires auditing and so on. But to a degree, it just works out of the box because of some existing good design decisions underneath that. And there's some work there to try and make modal dialogues not pile up a huge stack of pain. So I'm told I only have like 30 seconds to questions come. So, so I'll just bash through some of the stuff in 6.0. One of the things I'm excited about is, well, the EPUB 3 is pretty nice. Mail merge was always a bad idea from spreadsheets. You should probably use a database for your contacts. It's an even worse idea for tables in Writer. But we unfortunately have a customer that stores their address book as a word processor table and then wants to mail merge from it. Bless them. And they can now. And do bless them. We need more customers. So OpenPGP is, again, really cool. Signing and encrypting documents there. So, some fun stuff. Better filters, better round tripping. The EMS stuff is really nice there from, I think, Volunteer. Improving previews. Better ergonomics. Improved notebook bar. We dropped support for Windows XP and Vista. Ha ha ha. Hooray. At last. I mentioned these APIs have a long tail. And we have angry people, particularly in Russia, who complain about Windows XP, which is strange. And of course, loads of stuff in online as well. There's just a whole slew of features there. The Android version is coming on nicely. So pictures from cameras being inserted, presentation modes. There's some exciting stuff from Jan Iversen and Jan Nurmut on iOS, which is coming, and probably we'll see that later. But what you should do is you should think, this is an awesome project. I could get involved. I could do something. I could make a difference here. We got dozens of other big projects in the world that are duplicates of other ones, but LibreOffice stands alone. It's the open source word processing project, out there. And, come and make it better. It's awesome. There's something for everyone. There's links you can click. There's fun stuff. And one of the nice things about it, as compared to writing a small Python script, is that the problem domain is so large, you cannot fit it in your head. So the techniques you learn working on LibreOffice are the big, grown-up engineering techniques that you're going to need. And once you've grasped them and you're confident with them, you can work on anything. You can do anything. It's like a Superman training school, I mean, I didn't learn anything, but I tell you, some of my colleagues are just amazing. And so I've got a paper on this, and you can read it. It's quite fun. And just getting a good structured approach to solving big problems in a way that you break it down and actually make progress. Cool. So yeah, we need smart people. But what we really need is that we live in a world of AI and technology, and increasingly this is automating everything we do. Documents should be no different. So what we really need is an AI of incredible subtlety, and I hope some of you are into convolutional neural networks and data sets and training that can see what you're doing and suggest cool new things to make it easier. So yeah, that would be absolutely brilliant if we could go there. So, conclusions. Well, there you go. Forced platform change really sucks, and it's tough on us. When I see that little hack to clean up GTK to remove the threading support that we've unfortunately broadcast to 200 million users in our programming API, I feel sad inside, But on the other hand, I know that GTK3 will never die, at least not for the next 15 years. So, anyway. Restructuring, refactoring, it's fun and it's risky. It is risky to some degree. And today it may seem hard to justify, but tomorrow you wish you'd done it. Stopping doing it is also extremely risky. And we seem to be surviving the volume of change, improving and growing, which is cool. Online is awesome. Free your data, share it with people, federate it, control it. Don't give it to a large evil or not evil corporation. Just keep control of it. And yeah, people are always welcome. So thanks so much for supporting LibreOffice and listening to my talk. Very good.
We have a few minutes for questions. Are there any questions?
Do you have any unit tests for user interface, like emulating user clicking, typing text, and checking if the results are correct? And if so, what do you use for such unit tests?
That is a fantastic question. So we have a chap in OpenQA, I mentioned, QA called Rob, who's come exactly to be trained on that. We have a Hackfest later. Marcus with the red shirt over there, waving a hand right now. Wrote the infrastructure to do that for the Document Foundation. It's built into our toolkit because it really needs to be. And yeah, we do have some degree of those tests. And you can run them in Python, I believe. And they're quite simple to do. Great way to contribute. If you find a bug and you don't want it to come back, write a test for us. Make sense?
You said you had some issues with threading, as everyone does. Do
Yes.
you have, there's nice frameworks and libraries in C++ now to ease the development, like HPX, Boost Fibers. Did you look at those? Do you plan to use one?
Yeah, so do we plan to use the new C++ features? So yes, definitely for threading. I suppose so. So we have a threading abstraction, of course, that's old, and we're trying to move away to that to more standard C++. There are benefits to that, and it's quicker in some ways. I think that, yeah. So there are a number of things to be said about contended mutexes and critical sections and standardization and Windows not working well and other things, but why not? Come and get involved, make our code look beautiful. That would be cool. Anyone else? A gentleman over here.
Hi. I work for a government department that's recently adopted Office 365 for all our staff. Are we locked in forever, or is there some way where you can help us move in the future?
So when you say you've adopted Office 365, what does that actually mean in practice? Because if you're using the online editing functionality of Office 365, you rapidly discover it's less functional than Collabora Online, which is only 2 years old. And, it's not a tool that you use. So what you tend to use is the PC version. And actually, if you use Office.com and this thing, you discover that almost anything you do, there's an advert for. You can't really do that here. Try it in your PC version. So I think often the use of Office 365 is a data store, which you shove documents into, which are in a non-standard but popular format we understand, to some degree. And then a PC version of an Office suite. As Larry Ellison said, if cloud is the new, if orange is the new black and cloud is the new whatever, then we'll make cloud press releases and branding. But I don't know. How tied are you to the actual cloud web service piece, or is it really still documents?
I don't know.
Yeah. So be scared, but perhaps not incredibly scared. And consider using Nextcloud, OwnCloud, PyDOC file, any of our the open source alternatives that can now actually, in many cases, do better.
Actually, Office 365 is subscription service.
Right. Okay.
And as you stop paying for it, you basically have to remove your software from your PC.
Sure.
And it's a standard way to get Office running, but it's basically you are not tied forever. You will eventually decide it's not worth to pay that. And actually very costly.
Yep.
Yeah, that might point out.
So I think there's a lot of truth in that. Yep. Anyone else? Gentleman at the front here. I will. Here we go.
It's a big project. How do you balance new contributions versus the code quality to keep it maintainable? I mean, it's a balance that any project leader has to make. What do you do?
Absolutely. So just to be sure, just to be clear, I don't lead the project. I merely participate to a degree. We have a sort of collective leadership thing. There's an engineering steering committee, blah, blah, blah. So first perhaps slight improvement on that. But yes, so it's a difficult balance. We are not blessed with a vast number of competent new people who want to contribute. So you will be welcomed. Don't worry about that. But in terms of trying to steer people away from obviously dangerous things with very little benefit, occasionally we do have people that seem to insist on wanting to do just cosmetic changes of almost no benefit. And that can be distressing. But the good news is that if people don't want to review it, it just piles up in their review queue.
So I'm asking how you, because that's always an issue for me.
Yeah.
For your project, how do you handle that?
Yeah, so I mean, it's a resourcing issue, isn't it? How much time can you spend to try and bring new people on and get them into the code? We like to think we're a bit of a tar baby. People get, they can't escape after a while. So even though they say they do, they stick to it. And there's so much low-hanging fruit. It's easy to, read 10 files and find lots of things to do. So, yeah, do have a go. I think that's my time. Thanks very much.
All right, thank you, everyone. Michael Weeks.